Hello student, welcome and very good morning to you. Today I will be discussing the electric field of chapter number 29, electric field and potential, and I will be solving the numericals related to electric field of this chapter from numerical 34 to numerical number 50. This video will be extremely helpful for you. Please write a comment on this video because this comment will be extremely helpful for me to make the next video for you. Now let's start. First of all, definition. Electric field intensity in a point is the force per unit charge acting on a vanishingly small test charge. Look at this. Electric intensity E is equal to limit Q naught tends to 0 F by Q naught. Okay. Suppose Q charge at this point. Q naught charge is placed at a distance R from Q. So force experienced by Q naught due to Q charge is directed along this direction, and this force becomes F equals to, this is the Q naught by 4 pi epsilon naught r square, that is k q naught by r square, where k equal to 1 by 4 pi epsilon naught. So electric intensity E equal to, this is the F by Q naught. So look at this is the kq by r square. Okay, understood? Due to positive charge, electric field intensity is directed away from the charge, and due to negative charge, look at this, due to negative charge, the electric field intensity is directed towards the charge. Okay, now some numerical related to this theory. Okay, now look at this is the example of HC Verma. The electric force experienced by a charge of 1 into 10 to the power minus 6 coulomb is 1.5 into 10 to the power minus 3 Newton. Find the magnitude of the electric field at the position of the charge. Okay. Here force F equals to 1.5 into 10 to the power minus 3 Newton is given. Charge Q, this equals to 1 into 10 to the power minus 6 coulomb also given. So electric field, force per unit charge. So F by Q is the electric field. So this is the 1.5 into 10 to the power minus 3, and this is the 10 to the power minus 6. So look at this. This is the 1.5 into 10 to the power minus 3 Newton per coulomb is the magnitude of electric field. Okay. Look at this question number 36. If one charge produces an electric field of magnitude 5 Newton per coulomb. So look at this, here electric field E is given. This is the 5 Newton per coulomb. At a distance of 40 centimeter, here also R is given. This is the 0.4 meter. We have to calculate the magnitude of charge Q. Okay. Now E equal to, this is the KQ by R square. Now here E equal to, this is the 5, K is the 9 into 10 to the power 9, Q is to be obtained, and R is the 0.4 whole square. Okay. So look at this, here Q equal to 5 into 0.16 divided by 9 into 10 to the power 9. So look at this is the 0.8 divided by 9 into 10 to the power 9. Look at this is the 9 into 10 to the power minus 11 is the magnitude of charge in this position. Okay. Now look at this. Suppose, look at this is a line. The two charges Q and Q are placed at the separation of 2r. We have to calculate the magnitude of electric field at the midpoint O. So look at this. Due to this charge, electric field is directed along this direction, and magnitude of this electric field, this is the kq by r square. At this point, electric field to this charge is directed along this direction, and magnitude of this electric field, this is the kq by r square. Look at this equal electric field are directed in opposite direction. So net electric field is equal to 0. Now look at this. If the q and minus q charge are placed at the distance of separation 2r, the electric field at the midpoint between the line joining the two charges. Look at this. Due to q charge, electric field is directed. This is the kq by r square. And due to minus q charge, it is directed towards this charge and same magnitude. So net electric field is the 2 kq by r square. Okay, understood? Now look at these two particles A and B having charges. This is the 2 into 10 to the power minus 6 coulomb and minus 4 into 10 to the power minus 6 coulomb respectively, are held fixed at the separation of 20 centimeter. Locate the points on the line AB where electric field is 0 and electric potential is 0. First of all, electric field is 0. Now look at this. This is the charge 2 into 10 to the power minus 6 coulomb, and this is the minus 4 into 10 to the power minus 6 coulomb. Look at this. Between the two charges, electric field never 0, because here electric field always directed towards positive charge to negative charge. Now we get a point somewhere at this position where electric field becomes 0. Look at this. Due to this charge, electric field directed away from the charge, and due to negative charge, electric field directed towards this charge. So suppose this distance is x where intensity becomes 0. So if this is the x, so the distance of this point from this charge, this obviously 20 centimeter, that is 0.2 meter plus x from this charge. Okay. So as electric field is 0, so look at this. This is the k into q. Q means 2 into 10 to the power minus 6 by x square. This equals to k into 4 into 10 to the power minus 6 divided by 0.2 plus x whole square. Okay. Now look at this. This cancel out. This and this cancel out. This and this cancel out. So look at this. 1 by x whole square equals to root 2 divided by 0.2 plus x whole square. Okay. No problem. Therefore, root 2x equals to 0.2 plus x. Therefore, x into root 2 minus 1 equals, this is the point. Therefore, x equals to 0.2 divided by root 2 minus 1. So, x equals to, look at this, root 2 into root 2 plus 1. Look at this, 0.2 into root 2 plus 1 divided by 2 minus 1. Okay. So, look at this, root 2 plus 1 means 2.4 into 0.2. So, this is the 0.48. Okay. Therefore, electric field is 0 at a distance 48 centimeter from the 2 microcoulomb charge. Okay. Next. Look at these three charges, each equal to q, are placed at the three corners of a square of side A. Look at this. This is the q charge. This is the q charge. This is the q charge. Find the electric field at the fourth corner. Side is equal to A. Okay. Now, suppose this is the A, this is the B, this is the C, this is the D. So electric field due to charge, look at this, electric field due to this charge at A, this is the kq by A square. Suppose this is the E1 and directed away from. So here U1 is equal to KQ by S square. Now electric field due to charge Q at C is directed also along this direction, and this also KQ by this is the S square. Look at this, BD distance is equals to root 2 into A. So due to this charge, electric field is directed along this direction. Look at this. This is the E3. E3 equal to this is the KQ by root 2A whole square. So look at this. This is the half KQ by A square. Okay. Now this is the E2. Now this angle is 45 degree. This angle also 45 degree. So net electric field, look at this, E equal to this is the E1 cos 45 degree plus E3 cos 45 degree plus this is the now component of E1 along this direction, this is the E1 cos 45 degree. Component of E3, component of E2 along this direction, this is the E2 cos 45 degree. So net electric field, this is the E1 cos 45 degree plus E2 cos 45 degree plus E3. So look at this is the 2 into KQ by A square plus 2 into KQ by square into 1 by root 2 plus E3 is the KQ by 2A square. So look at this is the root 2 KQ by A square plus KQ by 2A square. So look at this KQ by A square. This is the root 2 plus 1 by 2. So look at this. This is the KQ by 2A square. This is the 2 plus 1. Okay. Understood? Next. Suppose a charge particle Q is placed in an electric field E. So force acting on the charge particle F equals to Q E vector. Therefore, a positive charge experiences a force in the direction of field, and a negative charge experiences a force opposite to the direction of the field. Now, axis of the charge particle, this is the F by M. So look at this. This is the QE by M. No problem. Therefore, velocity of the charge particle after the time t, this equals to V equals to AT. Therefore, look at this. This is the QET by M. Okay. Now, distance travel S equals to this is the half AT square. So, look at this. This is the half. This is the QE by M into T square. So kinetic energy of the charge particle Ke equals to this is the half mv square. So look at this. This is the half m. This is the q square e square t square by m square. So look at this. K kinetic energy K equal to this is the q square e square t square by 2m. Okay. Now suppose this is the x-axis and this is the y-axis. Electric field E is directed along the y-axis. A charge particle moves along x-axis with velocity v. Okay. Now we have to calculate deflection of the charge particle in normal electric field E. After the time t, the charge particle reaches the point, suppose this is the px comma y. Therefore, the horizontal distance, therefore distance traveled by the charge particle along x-axis, this is the x, and deflection of the charge particle, this is the y. So look at this here, time t equal to this is the x by v. Now deflection y equals to this is the half a t square. So look at this is the half a into x square by v square. Here, action of the charged particle in electric field E is the force by mass. So look at this, force is the electrical force QE by M into x square by v square. So deflection y equal to, this is the QE x square divided by 2mv square. Therefore, y proportional x square. Therefore, trajectory of the charged particle in normal electric field is parabola. Okay, look at this. Look at this. A uniform electric field is created between the two parallel charge plates as shown in the figure. Look at this. This is the positive charge and this is the negative charge. An electron enters the field symmetrically between the two plates with speed a. The length of each plate L and the angle of deviation of the path of the electron as it comes out from the field. Now look at this. Here we have to calculate the vertical component of velocity Vy. Look at this. Here force on electron. This is the F equal to, this is the E into E. So acceleration of it, this is the, look at this is the E by F. No problem. Now time taken by the charge particle to reach from this point to this point, this is the T equals to L by V naught. Therefore Vy equals to, this is the A into T. Therefore this is the L by mv naught. Therefore, angle made by the charge particle with the x-axis, this is the tan theta, this is the Vy by V naught. Now look at this. This is the EEL by, this is the mv naught. So this is the mv naught square. Angle made by the charge particle with the x-axis. Okay. Next problem. Look at this. Question number 37, HC Verma. A water particle of mass 10 mg and having a charge 1.5 in 10 to the power minus 6 coulomb stays suspended in a room. What is the magnitude of electric field in the room and what is its direction? Look at this. Here charge is positive and weight mg always vertically downward. No problem. So electrical force must be in upward direction such that the net force becomes zero. So look at this here, mg downward direction and qe upward direction. As charge is positive, so electric field is directed in upward direction. So look at this here, magnitude of electric field, this is the QE equal to mg. Therefore, E equal to, this is the mg by q. Now put the value here. E equal to, look at this, mg. Mg means 10 milligram. So look at this, 10 into 10 to the power minus 6 into, this is the 10 Newton. Divide by q. Q is the 1.5 into 10 to the power minus 6. Look at this, 10 to the power minus 6, 10 to the power minus 6 cancel out. So look at this is the 100. So this is the 1000 by 15. Okay. So look at this is the 200 by 3. So 67 Newton per coulomb is the magnitude of electric field. Okay. Look at this, sum number 38. Three identical charges, each having a value of 10 to the power minus 8 coulomb, are placed at the corner of an equilateral triangle of side 20 centimeter. What is the electric field and potential at the center of the triangle? Now look at this. This is an equilateral triangle. Okay. Now charges, look at this. This is the Q. This is the Q. This is the Q. The electric field at the center due to Q charge. Look at this. The electric field at the center due to Q charge is directed along this direction, and electric field due to this charge at the center is directed along this direction, and electric field due to this charge at the center is directed along this direction. Look at this. Here three electric field makes an angle of 120 degree with each other and all have same magnitude. So net electric field E equal to 0. Okay. And net potential as potential is scalar quantity, so is the 3kq by r, where r is the distance of center of the triangle from each charge. Okay. Now electric field intensity due to different bodies. First of all, spherical shell. Spherical shell or conducting sphere has only surface density of charge. So charge reside over the surface. Suppose radius of the spherical shell is capital R. Look at this. This radius is capital R. We have to calculate intensity at the point P at a distance R from the center. So E equal to, this is the kq by R square when R greater than equal to capital R, and E equal to 0 when R less than R. If we plot a graph between E and R, the graph starts at smaller equal to capital R. Look at this. Start here. And this graph this. So here E proportionate 1 by R square. Now electric intensity due to insulating sphere. You know, insulating sphere has volume density of charge. That is, charge reside within the volume of it. If capital R be the radius of it, and we have to calculate the intensity at the point P at a distance R from the center of the insulating sphere, then look at this. Here E equal to, this is the kq by R square when R greater than equal to capital R, and E equals to, this is the kq smaller by RQ. Look at this here when R less than capital R. So within the smaller, so within the insulating sphere, E proportionate R. Okay. Now look at this. This is the R. This is the E. Okay. Now look at this. This is the outside, and inside it is a straight line. Okay. Here E proportionate R, and here E proportionate 1 by R. Okay. Now intensity due to a ring of radius capital R on its axis. Okay. Suppose x be the distance of the point P on its axis of the ring having radius capital R, and charge in it is q. The intensity at the point P, this is the kq by kqx divided by, this is the r square plus x square to the power, this is the 3 by 2. Okay. Now intensity due to rod at its perpendicular bisector position. Look at this. Suppose this is the perpendicular bisector position. We have to calculate intensity at this point. So at this point, intensity is the, look at this, E equal to, this is the k lambda by R. This is the sine theta 1 plus sine theta 2. This distance is the R. Okay. And this angle, look at this angle theta, and this angle is also theta. Okay. No problem. We have to calculate the intensity due to a quarter circular ring having linear density of charge lambda. Due to this, the electric field along this direction, this is the Ex equals to, this is the k lambda by R, and along this direction, this is the Ui, this is the k lambda by R. Okay. Now look at this question number 9. A positive charge Q is distributed uniformly over a circular ring of radius R. A particle having a mass small f and a negative charge minus Q is placed on its axis at a distance x from the center. Assuming x less than r, and the time period of oscillation of the particle. Okay, now look at this. This is the ring. Its radius capital R and charge on it is capital Q. Okay, look at this. Its radius is capital R. Now we have to calculate the force on minus Q due to this thing. Okay, now intensity at this point due to charge Q, this is the KQX, this distance is the X, okay, divide by, this is the R square plus X square to the power 3 by 2. So force on negative charge F equal to, this is the minus Q into E. So look at this is the minus KQQ X divided by R square plus X square to the power 3 by 2, as X less than R, so this becomes R. This is the force experienced by small q. This is the force experienced by small q due to capital Q. Now here this force F proportionate minus x, so minus q charge execute SHM. If omega be the angular frequency, then F equals to minus m omega square x equals to minus k capital Q small q x by capital R. Now this and this cancel out, x and x cancel out. So look at this, omega equals to, this is the root under of k capital Q small q by m r k. Okay, no problem. Therefore t equals to, this is the 2 pi by omega. So look at this is the 2 pi root over m r cube divided by k capital Q small q. This is the period of oscillation where k equal to, this is the 1 by 4 pi epsilon naught. Okay. Now question number 40. A rod of length L has a total charge Q is distributed uniformly along its length. It is bent in the shape of a semicircle and the magnitude of the electric field at the center of curvature of the ring. Now, what is the linear density of charge? Now linear density of charge lambda equals to, this is the Q by length of it. If R be the radius of the semicircular path, so look at this is the pi R equals to L. Therefore, R equals to, this is the L by pi. Okay. Now look at this is the semicircular portion. Okay, no problem. It is divided into two parts, two quarter circle. Okay, this is the lower quarter circle. Okay, having linear density of charge lambda, electric field due to this section is, this is the Ex, this is the K lambda by R, and due to this section, this is the Ey, this is the K lambda by R. And due to the upper portion, look at this, having also linear density of charge lambda, this is the Ex along this direction and Ey along this direction. So net field, this is the E equal to, this is the 2Ex. Therefore, this is the 2K lambda by R is the electric field at the center. Now here R equal to, look at this, here R equal to, this is the L by pi and lambda equals to Q by L. So look at this is the 2 Q by L and this is the Q by L and this is the L by pi. Okay. So look at this is the, look at this is the 2 Q square by L square by pi and this is the 4 pi epsilon. Now pi cancel out, 2 to 4 and look at this, so Q square by, this is the 2 epsilon naught L square is the intensity due to the charges. Okay. Now question number 41. A 10 centimeter long rod carries a charge of 50 microcoulomb distributed uniformly along its length. Find the magnitude of the electric field at a point 10 centimeter from both the ends of the rod. Okay, look at this. This is a charge rod. Okay, its linear density of charge lambda. We have to calculate intensity at a distance r from the midpoint. The distance from each end of the rod is 10 centimeter. This also 10 centimeter. Length of the rod is 10 centimeter. Therefore, the distance of this point from the midpoint P equal to, look at this, P equal to this distance, capital R, this is the 10 square minus 5 square. So capital R is equal to, this is the, suppose this end is A and this end is B, this is the midpoint. So look at this, this is the AP square minus OP square. So look at this is the 10 square minus 5 square root under. So this is the 5 root 3 centimeter. Therefore, this is the 5 root 3 by 10 meter. Okay, we know for uniform linear density of charge of the rod, the intensity at the point P equal to, this is the K lambda by R into, this is the sine theta 1 plus sine theta 2. Okay, no problem. Where theta 1, where theta 1 is the angle here and theta 2 here angle here. Okay, here theta 1 equal to theta 2. Now sine theta 1 equal to sine theta 2, this equal to perpendicular by hypotenuse. Now perpendicular is the 5, hypotenuse is the 10, so this is the half. So look at this, the electric field E equal to K. What is the value of K? K is the 9 into 10 to the power 9. Lambda, look at this, lambda is the charge by length. Charge is equal to 50 microcoulomb by 10 centimeter. So look at this, 50 into 10 to the power minus 6 by 0.1. So look at this is the 5 into 10 to the power minus 6, 10 to the power minus 4. Okay, no problem. So look at this here, 5 into 10 to the power minus 4. Okay, now R is equal to, look at this is the 5 root 3 by 100 into sine theta 1, this is the half plus half. Okay, no problem. Therefore, E equal to, look at this is the 9 into 5 into 10 to the power 5 into, look at this 100 into 100, and 1 plus 1 is equal to 1 divided by, this is the 5 root 3. Now this 5 and this 5 cancel out, 9 divided by 9 divided by root 3. So this is the 3 root 3 into 10 to the power 7. Therefore, look at this is the 5.2 into 10 to the power 7 Newton per coulomb. Okay. Now look at this 43. A wire is bent in the form of a regular hexagon. Total charge Q is distributed uniformly on it. What is the electric field at the center? You may answer this part without making any numerical calculation. Look at this is a hexagon. It has uniform linear charge density lambda. Okay, no problem. The electric field due to this portion, look at this, at the center is directed away from it. In the same way, the electric field due to this point is also directed away from it. So electric field due to this part and this part are cancelled out. In the same way, electric field at the center due to this part and this part also cancel out. The electric field due to this part at the center and electric field due to this part at the center also cancel out. Therefore, net electric field becomes 0. Okay. Now question 44. A circular wire loop of radius A carries a total charge Q distributed uniformly over its length. A small length dl of the wire is cut off. Find the electric field at the center due to the remaining wire. Now look at this. First of all we have to calculate lambda. This is q divided by 2 pi a of the circular wire. Now look at this. This is the circular wire. Okay. Very small portion. Suppose this portion. This is the dl is cut from here. This length is cut from here. Now we know the electric field due to whole charge ring at the center is 0. Okay, no problem. Therefore, electric field due to remaining portion of the wire is E1 and electric field due to cut off portion dl is E2. Therefore, sum of these two electric field E1 plus E2 at the center becomes 0. Therefore, E1 electric field due to remaining portion is the negative sign of electric field due to dl. Now you know the electric field due to very small length lambda dl is equal to, look at this, this is the charge lambda dl divided by 4 pi epsilon naught into r into a square. Now, so this becomes minus k lambda dl divided by a square. Okay, no problem. And it is directed. Look at this, the electric field due to now electric field due to lambda dl directed from charge, directed away from the charge. So electric field due to remaining portion directed towards the dl. Okay, no problem. Now question number 45. A positive charge q is placed in front of a conducting solid cube at a distance d from its center. Find the electric field at the center of the cube due to charge appearing on its surface. Look at this, you know electric field due to charge appearing on the surface q divided by distance square. So this is the 4 pi epsilon naught d square. So electric field is the kq divided by d square. Okay. Now question number 46. A pendulum bob of mass 80 milligram carrying a charge of 2 into 10 to the power minus coulomb is at rest in an uniform horizontal electric field 20 kilovolt per meter. Find the tension in the thread. Suppose this is the position of the pen. Look at this. This is the fixed point. Now a pendulum be equilibrium at this point. Okay, no problem. The initial position of the pendulum, look at this here, vertical. Okay. Look at this. This is the bob. This is the bob. Okay. So look at this. This is the electric force. This is the Q into E. And this is the gravitational force. This is the mg. We have to calculate tension T. Now look at this QE. Look at this, the electrical force Fe equal to Q into E. 2 into 10 to the power minus 8 is the, look at this, this is the 20 into 10 to the power 3. Look at this, 20 into 10 to the power 3 volt per meter. So look at this, this is the 4 into 10 to the power minus 8 Newton is the electrical force. Now gravitational force, look at this, gravitational force Fg equal to mass into g. Mass is equal to, look at this here, mass is equal to 80 gram. So here mass 80 milligram. So 80 into 10 to the power minus 6 into g is the 10. Therefore, look at this, this is the 8 into 10 to the power minus 4. Therefore, tension T equal to, look at this, tension T equal to, this is the under root of, this is the Fe square plus this is the Fg square. Okay, no problem. So look at this. This is the Fe. This is the 4 into 10 to the power minus 4 whole square, plus this is the 8 into 10 to the power minus 4 whole square. This is the root under. No problem. So look at this. This is the 4 into 10 to the power minus 4 root under 1 plus this is the 4. So look at this. Force is the, so tension is the 4 root 5 into 10 to the power minus 4 Newton. Okay. Next. Now question number 47. A particle of mass m and charge q is thrown at a speed of u against a uniform electric field E. How much distance will it travel before coming to momentarily rest? Look at this here. Initial velocity equal to E, final velocity v equal to 0, and retardation A equal to, this is the QE by mass. Okay, no problem. Therefore, look at this. This is the 0 square equal to u square minus 2 into A into S. Therefore, S equals to, this is the u square by 2 into A. This is the u square divided by 2 into, this is the QE by M. Okay. Therefore, look at this. This is the mu square by 2QE is the distance travel before coming to momentarily rest. Okay, no problem. Look at this 49. A particle of mass 1 gram, charge 2.5 into 10 to the power minus 4 coulomb is released from rest in an electric field 1.2 into 10 to the power 1.2 into 10 to the power 4 Newton per coulomb. Find electric force. Look at this. The electric force Fe equal to, this is the Q into E. Now what is Q? Q is equal to 2.5. This is the 2.5 into 10 to the power minus 4. What is E? E is the 1.2 into 10 to the power 4. This is the 1.2 into 10 to the power 4. So this is the Newton. Therefore 2.5 into 1.2. So look at this. This is the 3 Newton. Is the force, is the electrical force acting on the charged particle. No problem. And the force of gravity. Look at this. The force of gravity. So Fg equal to, look at this. This is the m into g. What is mass? Mass is the 10 to the power minus 3 kg and g is the 10. So look at this. This is the 0.01 Newton. So gravitational force is neglected in comparison to the electrical force. Okay. Now, how long will it take for the particle to travel a distance of 40 centimeter? Look at this. Here, acceleration A equal to, this is the force, this is the net force by mass. So as this force is neglected, so net force is the almost 3 Newton whole divided by mass. This is the 10 to the power minus 3 meter per second square. So look at this. This is the 3000 meter per second square. No problem. So time taken to travel the distance 40 centimeter t equal to root over 2s by a. Look at this here. T here 2 into s is the 0.4 meter. A is the, this is the 3000. Okay. So look at this. This is the 8 by 3 into 10 to the power minus 4. Okay. So look at this. This is the 2.67 into 10 to the power minus 2 second. Now 2.67, it is almost 1.63 into 10 to the power minus 4 minus 2 second. Okay, understood? What will be the speed of the particle after traveling this distance? Okay, so velocity v equal to, this is the a into t. What is the a? A is the 3000. Okay, t is the, look at this. This is the 1.63 into, this is the 10 to the power minus 2. Therefore, 30 into 1.63 meter per second. So look at this. This is the almost 49 meter per second. Okay. Now, last question. How much work is done by the electric force on the particle during this period? So work done is equal to force into displacement. Force is the 3 Newton. Displacement is the 0.4 meter. Therefore, work done is equal to 1.2 joule. Okay. Now, question number 49. A ball of mass 100 gram and having a charge of 4.9 in 10 to the power minus 5 coulomb is released from rest in a region where a horizontal electric field 2 into 10 to the power minus 4 Newton per coulomb exists. Find the resultant force acting on the ball and what will be the path of the ball and where will it the ball at the end of 2 seconds. Okay. Now, first of all, gravitational force. Look at this. The gravitational force Fg equal to, this is the mass into acceleration due to gravity. Mass is the, look at this, 100 gram, that is 0.1 kg. G is the 10. So look at this is the 1 Newton. Now, electrical force, look at this is the Q into E. What is Q? Q is the 4.9 into 10 to the power minus 5. This is the 4.9 into 10 to the power minus 5. And the electric field, this is the 2 into 10 to the power 4. This is the 2 into 10 to the power 4. Therefore, look at this is the 0.98 Newton. So look at this is almost 1 Newton. Okay, this is the electrical force in horizontal direction and gravitational force is equal to vertical direction. Therefore, net force is the angle bisector of these two because two forces are equal. So this force root under of 1 square plus 1 square, that is the root. Okay. Where will the ball is at the end of 2 seconds? To calculate the position of the ball at the end of 2 seconds, we have to calculate the acceleration due to electrical force. Look at this, the acceleration due to electrical force. This is the 1 Newton by 0.1. So this is the 10 meter per second square. This is the acceleration due to electrical force. And acceleration due to gravitational force, this is the obviously G. It is this is the 10 meter per second square. So distance, so horizontal distance travel. So horizontal distance travel x equals to, this is the half into a is the 10 into 2 square. So this is the 20 meter. Y is the same, this also 20 meter. Therefore, the position of the particle with respect to origin 20 comma minus 20. The question number 50. A bob of simple pendulum has a mass of 40 gram and a positive charge of 4 into 10 to the power minus 4 coulomb. It makes 20 oscillations in 45 seconds. Okay. So time period of pendulum t equals to, this is the 2 pi root under, this is the L by G. No problem. Here time period t equal to, this is the 45 divided by 20. So look at this is the 45 divided by 20. This equals to 2 pi. This is the L by G. G is the 10. This is equation number 1. Okay. A vertical electric field pointing upward of magnitude 2.5 in 10 to the power 4 Newton per coulomb is switched on. So vertical force on, so vertical force on the bob, this is the F equal to charge into charge into electrical field. Charge is the 4 into 10 to the power minus 6 coulomb. And look at this. This is the electric field. This is the 2.5 into 10 to the power 4. This is the 0.1 Newton. Now, vertical acceleration, this is the 0.1 divided by, this is the 40 by 1000. Okay. This and this cancel out. So look at this. This is the 10 by 4. So this is the 2.5. Now, net vertical acceleration in the downward direction of the bob, this equals to 10 minus 2.5 because G is vertically downward and acceleration A is the 2.5. So time period T equal to, look at this, time period T dash equals to, this is the 2 pi root under L by, this is the 7.5. Now we have to calculate time required to complete 20 oscillation. Suppose small t is the time required to complete 20 oscillation. So time period is the t by 20. This equals to 2 pi root under L by 7.5. Look at this. This is equation number 2. Now divide 2. Now equation 2 divided by equation 1. So look at this. T by this is the 45. This equal to this is the this equal to this is the 10 by 7.5. So look at this. This is the 1.33 root under. So look at this. This is almost 1.15. Therefore, T equals to 45 into 1.15. So this is almost equal to 52 seconds. Okay. So time required to complete 20 oscillation is 52 seconds. Many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, main and advanced. Please like, share and comment on it. And if you are new to get the higher mark in NEET, main advanced, subscribe my channel. Okay, thank you.